Hi, my name is Steve Bowler, and in this video I'm going to be configuring MPLS VPN. So what we're going to do is first I'm going to explain the topology, and then we're going to go into the routers and start configuring them up. As you can see here, we have a headquarters router and a branch router to simulate our customer's connection. In the ISP network above, we have ISP router 1, ISP router 2, ISP router 3, and ISP router 4. Within the ISP network, what we're going to be running on all the interior interfaces, we're going to be running EIGRP and MPLS. Now, excuse me, our links to our customer here, what we're going to do is we're going to be running version 2, and you can see here, looks like the premise edge, that would be ISP router 4 and ISP router 1 are premise edge routers, and customer edge routers are the headquarters and the branch router. And you can see here ISP router 3 and ISP router 2, those are called P routers. They're within the MPLS network. All their main purpose is to just switch the tags as they come through. They don't do any IP lookups on any of the external IP prefixes from headquarters and branch. All they're going to see is the labels, and they're just going to switch based on labels and not based on any IP information or any of the IP version 4 information. Okay, so what we're running here is we're going to be actually participating in the routing with the customer. And this type of VPN is called a peer-to-peer VPN. Traditionally, you had two types of peer-to-peer VPNs. You had shared router VPNs, or shared router peer-to-peer VPNs, and you have separate router VPNs. Shared router is where all your customers share the same router in a geographic area. They share the same router, and the ISP participates in the routing with the customer. However, as you can imagine, in that type of environment, trying to keep each customer separate is going to be very difficult, and you're going to have to filter a lot of routes and have very massive ACLs. And so that type of shared router peer-to-peer VPN is not a good design. You also had separate router VPNs where each customer had their own router, and as you can tell there, I mean, unless you have a lot of money, you're willing to throw out that kind of design where every customer has an ISP router per se. That can get very expensive to have the ISP manage all that for you. So what they've come out with is what's called MPLS VPNs, is where you can have multiple customers. Like in a shared peer-to-peer VPN environment, you get multiple customers connect to the same router, and they can be implementing RFC 1918 IP address scheme, where they use private IP address ranges, but the router, the ISP router, keeps all this information separate in separate routing tables. And they do that by implementing what's called VRFs, or virtual routing and forwarding tables, within the router. And we'll get in here and we'll configure your VRFs to do that, and keep that traffic separated. But that's one of the main things that they use, is different VRFs for different customers. They also run a different type of BGP. It's called multi-protocol BGP. It's used for different implementations, more advanced implementations of BGP, like multicast BGP, or what we're going to be doing is we're going to be running VPN version 4 BGP peers between ISP router 4 and ISP router 1. What this is going to allow us to do, this is going to allow us to filter customer routes based on what's called route targets, and we're going to be using route distinguishers within our virtual routing and forwarding tables to keep that traffic unique within the VRF. And so we're going to go through all that stuff. I know it seems pretty complicated right now, but we're going to go ahead and get started here doing some of the configuration on the routers, and then we'll go ahead and talk it through, see if we can get through some more of this theory, and see if we can make anything of it. So I'm going to go ahead onto the headquarters router first, and looks like I already have the terminal up here. Okay, so for the headquarters router, what we're going to do is what I've done already. I've already implemented